Hi, this is Balaji, assistant professor, Department of Mechatronics Engineering, SNS College of Technology. Uh, in our last video, we had discussed about super alloys, which is coming under the smart materials. Okay, so we have discussed about what is super alloys, how we can manufacture super alloys. So we have some kind of manufacturing process like casting, forging, then powder metallurgy additive manufacturing, and then we have discussed about super alloys and then classifications and then where it can be used. So like we can use the gas turbines, valve seats, engine wounds, and automatic engines, aerospace fuel nozzles. So those kind of application, what kind of superalloys we can use, we can have discussed. And then in your screen we can see many kind of components like high HP compressor, like LP compressor. Like HP compressor, for that application we can use the aesthetic steel. For the LP compressor we can use the ferritic steel. Like for the HP turbine, we can use the single crystal alloy plus the coating, and then we can use the directional solidify alloy from coating for the internal components like LP turbine, like nickel based superalloys and coating will be used. Rotor will be using the ferritic steel. The ferritic steel basically, it's a kind of low harness. It may be a ferrite based nickel alloys, and then combustor engine, it may be nickel based superalloy with the coatings. Okay, so we have discussed about the application of superalloys. So in this video we are going to discuss about what is what is shape memory alloy. Okay, so the shape memory alloys, it is a material that undergoes the phase transformation, which is experience the mechanical stress in temperature change. When the condition is a return to the normal, SMA, it will come to the original position. That is what the shape memory alloy. Like it's a remember, SMA means remember, it's the original shape and reverse to it. Okay, because when you're applying to the load in the screen, you can see that down the slide, apply to the load to the your original material, like original force, and after removing the force, removing a force, and then some heat treatment, any kind of work, it will be taken to the its original position. Okay, that is what available in the down the screen. Okay, the two crystal structure of SMA materials is known as the austenite and martensite. Okay, the austenite martensite, which are the materials which is available in our ion carbon diagram. You can see my last videos. You can check it. Okay, in austenite is SMA structure has a high temperature, while the martensite is the structure of lower temperatures. Okay, Astronite is the higher temperature, and then the matter is the lower temperature. The transformation of artensite use the astatite to macetite, vice versa, because of memory behavior. The common material for the SMAs include copper, aluminum, nickel, and copper titanium alloys, later often referred to as the nitinol. Okay. Nitinol, that means the basic alloy, which refers to elements nickel with titanium. That means nickel with titanium, where the first developed now developing novel origins laboratory about the SME alloy. Okay, like you can see the application of shape memory alloy. Like you can use it the aeronautic coupling, for the solid state actuators, and then SMA bone stables, and then self expanding stunt. Then the stunt is one of the major application in the medical applications, robotic applications. SMA tamper, which is used for to reduce the vibrations, to absorb the vibration, a glasses frames, and then SMA thin films and SMA auto applications, which will be tend to the original position when you're applying to the any kind of forces on the material. Okay, uh, so basically, you can see the shape memory alloy for the industry application. It's a remarkable property, which is known as the shape memory alloy, arise the reversible phase transformation. So it's coming under the two kind of crystals. Okay, like astenite crystal, which is the high temperature base, and then magnesite, which is the low temperature. Already I was discussed about. Okay, so we have a some mechanical properties, key properties are to the shape member alloy. So can can undergo the deformation and recover the original shape upon unloading, even the higher even at the temperature below the transformation temperature. Okay, the shape memory effect based on the reversible phase transformation between the ash and magnetized phases, which can be included by temperature stresses. Okay, some SMA can be with the two shape memory effects. Okay, like where the material changes shape amount cooling as well as heating, because if you're giving them some cooling, it will give another kind of shape. Okay, if you're giving them some heating source, it will give us some kind of spaces. Okay, so these are about the SMA. So shape memory ML, which is the important one. We have seen two kind of things. One is the matte site, another arsenic. So arsenic. So when you are applying to the load, it will get into the deformed, and then even after applying to the load, we'll be giving heating or cooling, be getting the original position. So basic example for the SMA is a which means nickel and titanium. Okay, that's what about SMA.